Hi everyone. In this lecture, we will study closure properties of non-regular languages. We have already seen closure properties of regular languages, closure property of context-free languages, closure property of DCFLs. Okay, so that we have already seen. Now, in this lecture, we will study closure properties of non-regular languages. See, one thing I want to tell you, when you study closure properties of regular languages, then basically there are two things you will focus. See, when you study closure property of any set S. Okay, so when you study closure property of a set S, then tell me, there are two categories you can create. Yes or no? There are two categories. Either an element belongs to S or it does not belong to S. See what I'm saying. When you study closure property of a set S, then there are two worlds. Those elements which belong to S, I can say, okay, either you will belong to S or you will not belong to S, right? Yes or no? So basically, when you study closure property of a set S, then I can say the world is divided into two categories. You can divide the entire world into two categories. Okay, either element will belong to S or element will not belong to S. Similarly, when you study closure property of CFLs, then what we say, then what is our focus? When you study closure property of CFLs, then our focus is that either the language will be CFL or the language will be not CFL, right? Yes or no? So when you study closure property of CFL, do you care about whether this L is regular, whether this L is DCFL? Do you care about it? Tell me. No. See, when you study closure property of CFLs, you only care about this, that a language is either CFL or it is not CFL, right? Similarly, when you study closure property of a set S, then I can say only these are the two things you will focus. Either this element will belong to S or this element will not belong to S. Similarly, if you study closure property of regular languages, what you will focus on? If you study closure property of regular languages, then tell me what your focus will be. Let me know. When you study closure property of regular languages, then your only focus is either this language is regular or this language is not regular. Yes or no? Either this language is regular or this language is not regular. Okay, see, when you study closure property of regular languages, when you study this, now then we don't care whether this L is CFL, whether this L is not CFL, whether this L is DCFL, whether this L is not DCFL. We don't care. When you study closure property of regular languages, you only care about two things. Either this language will be regular or this language will not be regular. Now finally you tell me, when you study closure property of non-regular languages, then on what, then your focus will be on what? Tell me. When you study closure property of non-regular languages, then your focus will be on what? Your focus will be on either this language will be non-regular, or this language will be regular. Yes or no? Either this language will be non-regular or this language will be regular. Agree? Please tell me, is this clear? See, is this clear? When you study closure property of non-regular languages, then either the language will be non-regular or the language will be regular. Now, I do not care whether this L is CFL, this L is DCFL, this L is not CFL. I don't care. Okay. So when I study closure property of non-regular languages, then I only care about two things. Either L is non-regular or L is regular. I don't care whether L is CFL, whether L is DCFL. I don't care. Okay, I only care L is regular or L is non-regular. Okay, this is what I care. Okay, so let's see. When you study closure property of non-regular languages, then what is your base set? Tell me, what is your base set? When you study closure property of non-regular languages, what is your base set? Your base set is set of all non-regular languages. Set of all non-regular languages. Yes or no? Okay, so your set will be, your base set will be set of all non-regular languages. Tell me what you have in this set. In your base set, what you have? This is your base set. In your base set, you have all the non-regular languages. This is your set of all non-regular languages. You have all the non-regular languages you have. Tell me, do you have sigma star in this set? Do you have sigma star in this set? No, you don't have sigma star. But what you have, tell me. For example, you have a power n, b power n. This you have. For example, you have a power n, b power n, c power n. This also you have. Yes or no? For example, you have w, you have. For example, w reverse you have. Agree? Okay, so these type of languages you have. Basically, all the non-regular languages you have here. Okay, please tell me, is this point clear? So like this you can see. I hope this point is clear. For example, number of A equal to number of B. This also you have here. Okay, this language you also have here. So these languages, all these languages which are not regular, all these languages you have. Okay, so I hope this point is clear. For example, A power prime, that also you have. This is non-regular. So this is the idea. So remember, closure property of non-regular languages. When you study closure property of non-regular languages, then your base set is set of all non-regular languages. And what is the question? What is the question? The question is, if I take two languages from here, I take a language L from here, I take a language M from here. Yes or no? I take two languages from here, I apply some operation between them, and will the result be a non-regular language? Yes or no? That is the question. I apply some operation between them, and then I ask, will the result be non-regular? Will the result be non-regular? This is the question. I take two non-regular languages, I apply some operation, and then I will ask, will the result belong to non-regular set? Means will the result be non-regular? Okay, so this is the complete idea. Please tell me, so far is it clear? Let me know. So far is it clear? Okay, so very simple. We are learning closure properties of non-regular languages. Okay, means you have two non-regular languages. L is non-regular. Also M is non-regular. On these languages you apply some operation. And then you ask you, is it regular or is it non-regular? Then you ask, is it regular or is it non-regular? This is the question you will ask. Is it always non-regular? Okay, this language, will this result be always non-regular? Okay, so this is the question. Now let's see the first one. What do you think about complement of non-regular language? What do you think? Complement of a non-regular language. Will it be non-regular or can it be regular also? Tell me. The complement of non-regular language. If L is non-regular, let's assume L is non-regular language. What you can say about L complement? This L complement, can it be regular? Tell me, this L complement, can it be regular? No, it will be non-regular. Okay, it will be non-regular. So complement of non-regular language will always be non-regular. If a language is not regular, then the complement also will be not regular. So remember, the complement of non-regular language will be non-regular. Can you prove it? I am saying if L is not regular, then complement also will be not regular. Can you prove it? Anyone? You can prove it using contradiction. See, non-regular languages, they are closed under complement operation. Okay? Means if you have a non-regular language, you do the complement, then the result will be non-regular. So this is the result. Non-regular languages are closed under complement operation. Means if you have non-regular language, and the complement, then the complement also will be non-regular. Is this clear? So can you prove it using contradiction? See, the proof is very easy. First of all, what is your theorem? What is the theorem? The theorem is like this. If L is non-regular, the language L is not regular, then L complement is also not regular. Okay, so you can notice If L is not regular, then L complement is also not regular. This is the theorem. Let's prove it. Let's see the proof. Can you prove it using contradiction? Can you prove it using contradiction? What is given to you? It is given to you that L is not regular. Yes or no? It is given to you that L is not regular. This is given to you. This is given to you that L is not regular. This is given to you. This is given. Now, assume L complement is regular. Just assume. I am assuming. Assume that L complement is regular. Okay, assume L complement is regular. If L complement is regular, assume L complement is regular, then what will happen? This is regular. See, this is regular. Let's call it M. This is regular. Okay, this is regular. Then what will happen? Then what can you say? This M complement also will be regular. Agree with me? Yes or no? Please tell me. See, I am saying this is given to you. L is not regular. Language L that is not regular. Assume, okay, just assume that complement of L is regular. Just assume. Now this complement of L, let's call it M. This is regular. That means M complement. See, M is regular. M is regular. So what you can say about M complement? Tell me. M is regular. This language M is regular. So what you can say about M complement? That will be regular. And what is M complement? What is M complement? M complement is same as L complement, whole complement. That will be L. And that will be regular. Did you get a contradiction? Did you get a contradiction? Here you are saying L is not regular. Here you are saying L is regular. Did you get a contradiction? Did you get contradiction or not? So this is your contradiction. This is the contradiction. So finally I can say my assumption is wrong. I can say my assumption is wrong. So I can say L complement is not regular. So is this proof clear? Please tell me. The proof is very simple, right? Yes or no? Very elegant proof, very simple proof. If L is not regular, if language L is not regular, then remember complement also will be not regular. Complement also will be not regular. And the proof is quite simple. You can easily notice if you assume L regular, then, okay, see, if you assume L complement regular, then what will happen? See, the proof is like this. The proof is quite simple. The proof is like this. It is already given to you. Again, I am telling you, it is already given to you that L is non-regular. This is given. This is given to you. L is non-regular. This is given to you. Okay. Now, just assume that L complement regular. Just assume that L complement regular. If L complement is regular, then we know that complement of regular language will be regular. We already know this. We already know complement of regular language will be regular. So I can say L complement is regular. So its complement will be regular. So I can say its complement will be regular. And that simply means L is regular. And that is a contradiction. And that is a contradiction. Okay, this. They are creating a contradiction. They are creating a contradiction. So I can simply say that this assumption is wrong. I can say this assumption, my assumption is wrong. Okay, so assumption is wrong. So I can say hence proved. So I can say if L is not regular, then L complement is also not regular. Please tell me, did you understand this? Very simple proof. What about this one? Reverse of non-regular is non-regular. Can you prove it? What you can say about reverse of non-regular? What you can say about reverse of non-regular? If your language is not regular, can the reverse be non-regular? Can the reverse be regular? If the language is not regular, can the reverse be regular? No, the reverse also will be non-regular. See, I am saying that if L is not regular, if your language L is not regular, if your language L is not regular, then remember L reverse also will be not regular. Then L reverse, that also will be not regular. Can you prove it? Can you prove it? You can prove it using contradiction. Remember, non-regular languages are closed under reversal operation. Means if you have a non-regular language, if your language is not regular, then its reverse also will be not regular. If your language is non-regular, then the reverse also will be non-regular. Can you prove it using contradiction? Yes, again, you can prove it using contradiction. First of all, what is your theorem? Your theorem is simple that if L non-regular, if your language L that is non-regular, then L reverse will be non-regular. This is the theorem. This is the theorem that if L is non-regular, then L reverse is also non-regular. Now let's see the proof. The proof is again very interesting. Proof by contradiction. Very interesting proof that it is given that L is non-regular, right? Yes or no? It is given that L is non-regular. Now just assume. Okay, tell me what you will assume. You will assume that L reverse is regular. Let's assume L reverse is regular. Tell me, if L reverse is regular, we know regular reverse will be regular. Regular reverse will be regular. Yes or no? So if L reverse is regular, if this is regular, remember, if this is regular, then its reverse will be regular. Then its reverse will be regular. Okay. What is L reverse whole reverse? L reverse whole reverse. What is that? That is L. So you got that L is regular. Did you get a contradiction or not? Did you get contradiction or not? Here you are saying L regular. Here you are saying L non-regular. Did you get contradiction or not? Yes, we got a contradiction. We got contradiction. Okay. So that is the proof. That is the proof that if L is not regular, then L reverse is also not regular. Is this clear? Please tell me. Please tell me, did you understand this? So two important result I want to tell you. These are two very, I can say, important result. This is the conclusion so far. This is the conclusion so far. What is that? If L is non-regular, if L is not regular, if language L is not regular, then what you can say, tell me? Then what you can say, tell me? Then L complement also will be not regular. Then L complement also will be not regular, and L reverse also will be not regular. L reverse also will be not regular. If you notice one thing, you can create a if and only if statement. See. We know that if L is regular, then L reverse, I can say L complement will be regular, right? Yes or no? Notice. If L is regular, then L complement will be regular. This we already know. We already know that if L is non-regular, we also know that if L is non-regular, then L complement will be non-regular. Okay, so tell me, can you create a if and only if statement? Can you create if and only if statement? So I can create if and only if statement that L is regular if and only if L complement is regular. Okay, I can say this. I can also say L is non-regular if and only if L complement is non-regular. L complement is non-regular. Please tell me, did you understand this? Let me know. Is this clear? Please tell me. See, you already know if L is regular, then L complement will be regular. We have seen if L is non-regular, then L complement will be non-regular. Okay, so I can say we have if and only if statement. L is regular if and only if L complement is regular. L is non-regular if and only if L complement is non-regular. Okay, so this is the if and only if statement. Similarly, I can create for reverse also. I can similarly create for reverse. If L is regular, then L reverse is regular. If L is non-regular, then L reverse is non-regular. So I can create if and only if statement here also. L is regular if and only if L reverse is regular. L is non-regular if and only if L reverse is non-regular. So this is the conclusion. Is this clear? Please tell me. Let me know. Let me know. So this is important. We will use it many times. We will use it many times that non-regular complement is non-regular. Non-regular complement is non-regular. We will use it many times. Also, regular complement is regular. Okay, the proof we have seen. Please tell me, is this clear? Let me know. Is this understood? Let's see the next. Tell me the answer for this one. Non-regular union non-regular. Can it be regular? Can it be regular? Non-regular union non-regular. Can it be regular? Can it be regular? Can it be regular? Yes, it can be regular. Yes, it can be regular. Remember, so non-regular union non-regular. This may or may not be regular. This may or may not be non-regular. Okay, remember this may or may not be regular. This may or may not be regular. For example, very simple counter example you can give. Okay, can you prove? Can you give two non-regular languages? Give two non-regular languages L, M such that their union is regular. Such that their union is regular. Such that their union is regular. Can you give me? Can you give me? Give two non-regular languages whose union is regular. Let me know. Anyone want to give? See, quite easily you can give. Take any non-regular. See. Take any non-regular L. Take any non-regular language L. Take any non-regular language L. You take M equal to L complement. You take M equal to L complement. Tell me one thing. Is it guaranteed that M is non-regular? See, take any non-regular L. Take any non-regular L. Take any non-regular L. Now take M equal to L complement. Tell me, is it guaranteed to be non-regular? Is it guaranteed to be non-regular? Is it guaranteed? Is there a guarantee? Yes. Non-regular complement will be non-regular. L is non-regular. L is not regular. So the complement also will be not regular. So take any non-regular L. Then take M equal to L complement. L complement also will be not regular. Now what will be L union M? Tell me. What will be L union M? That will be sigma star. Is this non-regular? Is this non-regular? Is this non-regular? This is regular. This is regular. Yes or no? Is this clear? Please tell me. Is this point clear? So can I say non-regular union non-regular will be non-regular? Can I say this? Non-regular union non-regular will be non-regular. Can I say this? Can I say this? I cannot say this. Okay. So can I say non-regular union non-regular will be regular? Can I say this will be regular? Can I say this? Can I say this? This also I cannot say. This also I cannot say. Can you give me two non-regular languages whose union is non-regular? Can you give? Can you give me two non-regular languages whose union is non-regular? Yes, that is quite simple. You can take L equal to A power n, B power n. Okay, you can take M equal to A power n, B power 2n. You can take this. This is non-regular. This language is not regular. This language is also not regular. What is their union? What is their union? That is also not regular. That is also not regular. Okay, is this clear? Please tell me. Let me know. So very easily you can do this. So finally I can say that, remember, can I say non-regular languages, are they closed under union operation? Non-regular languages, are they closed? Non-regular languages, are they closed under union operation? No, they are not closed under union operation. They are not closed. Okay, they are not closed. The proof is quite simple. The proof is quite simple and beautiful proof. See, okay, because remember, take any non-regular language, that is your choice. Take any non-regular language L. Take any non-regular language L. Okay, you take M equal to L complement. Now this will be non-regular. Complement of non-regular is non-regular. We already know. If you have non-regular, then the complement will be non-regular. Okay, so complement of non-regular is non-regular. So take any non-regular L, then the complement will be non-regular. Now you can easily notice what will be the union. The union will be sigma star, and that is a regular, and that is regular. So this is quite simple. This proof is very simple. So you can notice non-regular languages, they are not closed under union operation. Okay, is this clear? What about intersection? What about intersection? Tell me. What about intersection? Non-regular, intersection, non-regular. What you can say about this one? If you have two non-regular languages, what you can say about their intersection? Their intersection may or may not be regular. Their intersection may be regular, may be non-regular, may or may not be non-regular, or I can say may or may not be regular. Their intersection may be regular, or their intersection may be non-regular. Can you give me two non-regular languages whose intersection is regular? Can you give me? Can you give me two non-regular whose intersection is regular? So give two non-regular. Give two non-regular languages L, M such that L intersection M is regular. Can you give me? Can you give me such language? Can you give me such language? Give two non-regular languages such that their intersection is regular. Yes, very easy. Take this a power n, b power n, where n is greater than equal to 0. And take this a power n, b power 2n, a power n, b power 2n, where n is greater than equal to 0. See, this is non-regular. This language is not regular. This language is not regular. What is their intersection? What is their intersection? Let me know. What is their intersection? Their intersection is this set containing empty string. This is regular, right? Yes or no? This is a regular. Is this clear? Please tell me. Or you can see, or you can notice just a simple example. Let me give you a simple example. Take any non-regular. Take any non-regular. Take any non-regular. Take any non-regular language L and take M equal to L complement. First of all, you tell me, if L is non-regular, is it guaranteed that this will be non-regular? Is it guaranteed? Is it guaranteed this will be non-regular? Yes. Yes. Now tell me what is their intersection. Tell me what is their intersection. L intersection M. What is their intersection? That is phi. That is phi. And this is regular. And this is a regular. Yes or no? Is this clear? Please tell me. So intersection of non-regular languages can be regular. Yes or no? Intersection of non-regular languages can be regular. Now give me two non-regular languages whose intersection is non-regular. Whose intersection is non-regular. Can you give me? Give me two non-regular languages whose intersection is non-regular. The idea is quite simple. Take any. Again, what you do? Take any non-regular language L. Take any non-regular language L. Then you take M equal to L. Just take M equal to L. Now tell me what is the intersection? What is the intersection? Tell me what is the intersection? Intersection will be L, which is non-regular. Intersection will be L, which is non-regular. Okay. Is this understood? Please tell me. These are simple points. Yes or no? All these are very simple points. Okay. All these things, these are quite simple. So you can notice, I can say that non-regular languages are not closed under intersection. Can I say? Non-regular languages, they are not closed under intersection. They are not closed under intersection. Okay. So quite simple. Now let's move on. What about non-regular minus non-regular? What about this? Non-regular minus non-regular. What about this one? Tell me. What can you say about this one? Again, this may or may not be regular. Again, this may or may not be regular. This may or may not be regular. This may be regular. This may not be regular. This may or may not be regular. Can you give me two non-regular languages whose set difference is regular? give two non-regular languages L comma M such that their set difference L minus M is regular. Can you give me? Can you give me? Tell me. Can you give me two non-regular languages whose set difference is regular? Tell me. This is quite easy. You can take L equal to M equal to same. Yes or no? Take any non-regular language. Take any non-regular language. Take any non-regular language L and take M equal to L. Okay, means take M equal to L. Now you can notice that L minus M, that is phi, and this phi is regular. This phi is regular. Yes or no? Can you give me two non-regular languages whose set difference is non-regular? Whose set difference is non-regular? Can you give me? Give me two non-regular languages whose set difference is non-regular. Quite easy again. Take any non-regular. Take any non-regular language L. Take any non-regular language L. Take M equal to L complement. Take M equal to L complement. Tell me what is L minus M? Anyone? What is L minus M? Those strings which belong to only L, not M. Those strings which only belong to L, not M. L minus M will be L. Very good. And this is non-regular. And this is non-regular. Okay, yes or no? So quite easy. So tell me now, what you can say? Non-regular languages, are they closed under difference? Non-regular languages, are they closed? No, they are not closed under difference operation. Non-regular languages are not closed under difference operation. Okay, I hope all these points are clear. Please tell me. Understood? So far, everything, every point, did you understand? Let me know. Okay. So remember, so far what we have seen, let me give you the summary. Let me give you the summary so far. So far we have seen that the complement of non-regular will be non-regular, right? This is the first thing that we have seen. That complement of non-regular will be non-regular. Okay. What is the second thing we have seen? What is the second thing we have seen? The reverse of non-regular, that also will be non-regular. What is the third thing we have seen? Non-regular union non-regular. Can you say anything? Non-regular union non-regular. It may or may not be regular. It may or may not be regular. It may be regular. It may be non-regular. So it may or may not be regular. Yes or no? It may be regular. It may be non-regular. Similarly, the same thing you can say for non-regular intersection non-regular, non-regular minus non-regular. Okay, the same thing you can say for all these three people. You can say the same thing. This is the summary so far. Now let's see. Let's move on. What about concatenation? Non-regular, concatenation non-regular. What about this one? Non-regular, concatenation non-regular. What can you say about this? Concatenation. Concatenation of two non-regular languages. If I concatenate two non-regular languages, what you will get? Tell me. Can I say result will always be non-regular? Can I say? Can I say result will always be non-regular? Again, this may or may not be regular. Again, this may or may not be regular. May not be regular. This may or may not be regular. Okay. So if you do the concatenation of two non-regular languages, the result may or may not be regular. Okay. Can you give me two non-regular languages whose concatenation is regular? Give two non-regular languages. Non-regular languages L comma M such that L dot M is regular. Is regular. Can you give me? Can you give me two non-regular languages? Can you give me two non-regular languages such that L dot M that is regular? Let me know. Anyone? Can you give me two non-regular languages whose concatenation will be regular. See, the proof is quite elegant, very, very beautiful proof I am going to give you. Okay, very beautiful proof I am going to give you. Just focus here. Very beautiful proof. Or I can say a very beautiful L comma M I am giving you. See, this is the idea. What you do, take any non-regular L. See, take any, that is your choice. Take any non-regular L. Is that clear? Take any non-regular L. Whatever non-regular you want, take it. Take any non-regular L. Okay. Then what you do, M equal to, see what you do, take any non-regular L. Now what you do, in this you add empty string, just, okay, just add empty string. Okay, and you consider this M equal to L complement. See, okay, just wait a minute. What I'm saying, I want two non-regular languages such that their concatenation is regular. This is what I want. What I'm saying, take any non-regular language L. That is your choice. Take any non-regular language L and take M equal to L complement. Is it guaranteed to be non-regular? Is it guaranteed to be non-regular? Is it guaranteed to be non-regular? Yes. Okay. So now you can notice they are non-regular. Now you tell me one thing, a simple point I'm asking. If in this non-regular, if I add just empty string, okay, in this non-regular, this is non-regular. If I add only empty string, will it remain non-regular? Only one string I am adding. Only one string I am adding. So if I add only one string, this also will be non-regular. Yes or no? This will also be non-regular. See, in a non-regular language, I am just adding one empty string I am adding. So this also will be non-regular. And similarly, in this M, which is L complement, okay, in this L complement, what I am adding? I am adding empty string. This also will be non-regular. Yes or no? Is this point clear? See what I am saying? Take any non-regular language L. What you do? Just add empty string. In this language, you include empty string. Similarly, now you take this L complement. This is also non-regular. In this also you add empty string. Okay, just add empty string in both of them. Now you tell me. So now what I have done, see, very simple. You take any non-regular, L, and then what you do? Then you add empty string. This also will be non-regular. Okay, we are just adding one string. This is also non-regular. Similarly, what you do? Now you take M equal to L complement. Take M equal to L complement. Okay, then also what you do? You add this empty string. Okay, just add this empty string. Now you cannot, this also will be non-regular. We are only adding empty string in a non-regular language. This is non-regular. In this, we are adding only empty string. Okay. Now you tell me, what can you say about L union this language concatenation, this language? Anyone want to tell me what is this? Notice. This is non-regular. Remember, this is non-regular. This is also non-regular. What is their concatenation? Their concatenation will be sigma star. Every string you will get, their concatenation will be sigma star. Every string you will get. And this is regular. Every string you will get. Yes or no? This is quite simple. I am asking, you have L, whatever language L you take, L union empty string. Okay, dot. L complement union empty string. Now tell me, how will you get every string of L? Can you get every string of L? Of course, this L, if you concatenate with this string, what you will get? This L, if you concatenate with this string, what you will get? You will get the entire L here. Similarly, this empty string with this L complement, what you will get here? You will get L complement here. Did I get all the strings? I got L also. I got L complement also. I got all the strings, yes or no? I got sigma star. And this is regular. I got sigma star, that is regular. Is this clear? Please tell me. Let me know. So you can easily notice this is non-regular, this is non-regular. The concatenation is regular. The concatenation is sigma star, that is regular. Is this clear? Please tell me. Let me know. Did you understand the proof? Please tell me. Let me give you another. If you want, let me give you another idea. See, give two non-regular languages such that their concatenation is regular. Okay, let me give you. Consider these two. Consider these two. L equal to, consider this language L. That is your epsilon, a power 2, a power 3, a power 5, a power 7, a power 11. Tell me what is this language? Tell me what is this language? That is your a power prime union epsilon. Union epsilon. Yes or no? Agree? Okay. Now take this. Tell me, this language L, is this non-regular? Is this non-regular? This language L, this is non-regular, right? A power prime. A power prime. This language is non-regular. This is non-regular language. Okay. Now you take M equal to, this. A power 4, a power 6, a power 8, a power 9, a power 10, a power 12. Tell me what is this language? Also take empty string also. Just include empty string also. Tell me, what is this language? Let me know. This language is a power composite. A power composite union empty string. Yes or no? A power composite union empty string. This composite, this is also non-regular. Yes or no? A power prime, that is also non-regular. This language prime, this is non-regular. Also a power composite, that is also not regular. Now tell me what is L dot M? Tell me what is L dot M? So your L is a power prime. This is your L, a power prime, union empty string. Your M is a power composite, union empty string. Tell me what is L dot M? What is L dot M? That will be sigma star. Yes or no? L dot M, that will be what? Tell me. That will be a power n, where n is greater than equal to 0, but n is not equal to 1. Okay, n is not equal to 1. You cannot create a. Yes or no? If you do the concatenation, you will get empty string, you will get a power 2, you will get a power 3, a power 4, a power 5, a power 6, a power 7, you will get everything. But you will not get a. Is this regular? Is this regular? Yes, this is regular, right? Yes or no? This is a regular. Okay. So this is another example. Please tell me, did you understand now? Let me know, did you understand? Please tell me. So remember, this is what I am saying, that non-regular concatenate with non-regular. This non-regular concatenation with non-regular. This may be regular. Yes or no? This may be regular. This may be regular. This is what I told you, that this may be regular. Can you give me two non-regular languages whose concatenation is non-regular? Now give me two non-regular languages. Give me two non-regular languages, L, M, such that LM is non-regular. LM is non-regular. Can you give me? Give me two non-regular languages such that LM is non-regular. Anyone? Anyone want to give? Very easy. Just take L equal to a power n, b power n. Okay. And take M equal to a power n, b power 2n, or whatever. A power n, b power 2n. Tell me what L dot M will be. Anyone? What L dot M will be? Let me know. What will be L dot M? See, notice this L is also not regular and this M is also not regular. What will be L dot M? That will be a power n, b power n, a power m, b power 2m. correct? And this is also not regular. And this you can easily notice, this is also not regular. Okay, this is also not regular. So this is the idea. So final conclusion, what is that? Final conclusion that non-regular languages are not closed under concatenation. Yes or no? Non-regular languages, they are not closed under concatenation. They are not closed under concatenation. So if you have non-regular dot non-regular, this may be regular, this may be non-regular. This may be regular. Remember, this may be regular, this may be non-regular. This may be regular or may be non-regular. Understood? Please tell me. All these points, are they clear? Let me know. So quite easy. So you can see non-regular languages are not closed under concatenation operation. Let's move on now. What about this one? Non-regular whole star. What about this? Can it be regular? Non-regular whole star. Can it be regular? Again, this may or may not be regular. Again, this may or may not be regular. This may or may not be regular. Can you give me a non-regular whose star will be regular? Can you give me? Can you give me a regular whose star? Okay, so what you do? Give a non-regular L. Okay, such that L star is regular. L star is regular. Give a non-regular L such that L star is regular. See, you can give L equal to a power prime. Yes or no? You can give a power prime. Agree? A power prime, a power prime. Just take this. A power 7, a power 11, a power 13. So a power prime. Tell me what will be L star? Anyone? In L star, which strings you can create? In L star, which strings you can create? Let me know. Which strings can you create? See, in L star, you will have empty string. In L star, you will have empty string. You will have every string which is in L. You can create which string? You can create a power 2. You can create a power 3. Can you create a power 4 in L star? In L star, will you have a power 4? Yes, a power 2, a power 2. So you will have a power 4. You will have a power 5. Will you have a power 6? Will you have a power 6? Yes, a power 3, a power 3. Will you have a power 7? Yes, a power 7. Will you have a power 8? Yes, a power 8. Take it 4 times. Take it 4 times. A power 2, a power 2, a power 2, a power 2. Take it 4 times. Will you have a power 9? Take it 3 times. Okay, did you notice what language we got? Tell me what language we got. We got a power n, where n is greater than equal to 0, but n is not equal to 1. Yes or no? And this language is also regular. This language is also regular. Is this clear? Please tell me. This language is also regular. Yes or no? Is this clear? Let me know. So I hope this point is clear. So quite easily you can see. So give a non-regular whose star will be regular. We have done it. Give a non-regular language L whose star will be regular. We have done it. Now give me a non-regular whose star will be non-regular. Whose star will be non-regular. Give me a non-regular whose star will be non-regular. Give me a non-regular language L whose star will be non-regular. Tell me. Can you give me a non-regular language L you give whose star will be non-regular? See, that is quite easy. You can give me a power n, b power n, n greater than equal to 0. What will be L star? Tell me. What will be L star? For this language, what will be L star? See, in L star, you will have this type of strings. You will have this type of strings: a power n1, b power n1, a power n2, b power n2, a power n3, b power n3, and so on, a power nk, b power nk, where k is greater than equal to 0. Where k is greater than equal to 0. These type of strings you have. Yes or no? Is this clear? See, this is your L. This is your L. In this language L, you have this type of string: AB, AA, BB, triple A, triple B. These strings you have in L. In L star, what you will have? In L star, you will have this type of string. You will have you will have AB, you will have AB, AB, you will have AA, BB, AB, you will have AB, AA, BB, AB, AB, AAA, BBB. Okay, so like this, these type of strings you will have. Is this clear? Please tell me. If your language L is this, then in your L star, you will have any combination of these. Okay, like you will have this type of strings you will have. You can notice you have these type of strings. Is this clear? Please tell me. So your L star is A power n1, B power n1, A power n2, B power n2, like this. Okay, and so on A power nk, B power nk, where k is greater than equal to 0. And this is non-regular. This language is not regular. You can note this language, this is not regular. Okay, is this clear? So finally, what I can say? I can say, what is the conclusion I can give? I can give this conclusion that if you have a not regular, then its whole star may be regular, may not be regular. This its whole star may be regular or may not be regular, or may not be regular. Okay, it may or may not be regular. This is the conclusion. Okay, so let's move on now. So you can notice that non-regular languages are not closed under Kleene star. Yes or no? Non-regular languages are not closed under Kleene star. They are not closed under Kleene star. So that's it. So we have seen everything. We have seen everything. Read this. Did we see this? Do you know the proof? The class of non-regular languages is closed under complement and reversal. Can you prove it? How will you prove it? Tell me. The class of non-regular languages that is closed under complement and reversal. How will you prove it? Prove by contradiction. Very good. Very good. You can prove it by contradiction. Okay. You can prove it by contradiction. You can see this. We can prove it by contradiction. So very easy. What about this one? The class of non-regular languages, they are not closed under union intersection Kleene star. We have already seen this. We have already seen this. Okay. Very simple, right? What about this question? What is the answer? Tell me. What is the answer for this question? Does it mean that union of two non-regular languages is regular? Union of two non-regular languages is regular? Does it mean? The answer is no. The answer is no. Can you give me two non-regular languages whose union is regular? Give two non-regular languages. Give non-regular language L, M such that L union M is regular. Give me such. Okay, give me such. That will be L union L complement. Yes or no? Okay, you can take L union L complement and give non-regular language L. Give non-regular language LM such that their union is non-regular. Such that their union is non-regular. Give me this type of languages. Give me this type of languages whose union is non-regular. Give non-regular language whose union is non-regular. For example, you can take A power n, B power n, union A power n, B power 2n, union A power n, B power 2n. So like this you can take. Okay. So very simple idea. Now let's move on. Now let's see this table. Look at this table. This is not a table. You don't have to remember this table. You just have to understand everything in this table. You have to understand everything in this table. What this table is saying. See, in this table, you have to understand everything. Let's understand union. Okay, let's make sure you are comfortable with union. Tell me, if A is regular and B is regular, what result you will get? If A is regular, B is regular, then what result you will get? Union. Focus on union. Focus on union. Take your copy pen. Can you take your copy pen? Let's do it. So if A is the regular, B is regular, what you can say about their union? That will be regular. Very good. Okay, so this is simple. Regular, union, regular will be regular. This you already know. regular, union regular, that will be regular. Okay. What about this? If A is regular, B is non-regular. What about this? What about this one? If A is regular, B is non-regular, what you can say? I am saying that A is regular, B is non-regular. What you can say about A union B? What you can say about A union B? Tell me. A is regular, B is non-regular. What you can say about A union B? This may be regular or this may not be regular. Yes or no? Agree? This may be regular. This may be regular or non-regular. Can you give me A comma B whose union will be regular? A is regular, B is non-regular. Can you give me such that A union B is regular? Give me, for example, if I take A equal to 5 and B equal to A power n, B power n, what is their union? Please tell me. What is their union? A union B, what is their union? Remember, A is regular, B is not regular. A is regular, B is not regular. What is their union? Their union will be B, which is not regular. Okay. What other thing you can give? Now give me regular and give me non-regular. Give me regular and give me non-regular such that union is regular. Can you give me such that union is regular? Can you give me a regular language and give me a non-regular language such that their union is regular? Yes, you can give, for example, sigma star, and here you can give A power n, B power n. Okay, you can notice the union will be sigma star. This union will be sigma star, which is regular. Okay, so quite easily, is this done? Please tell me, is this over or not? So you can notice, if A is regular, B is not regular, then the result may be anything, either means regular or non-regular. What about this? Are you comfortable with this? Please tell me. If A is non-regular and B is regular, if A is non-regular, B is regular, then the union may be anything. What about this? Non-regular, union non-regular. A is non-regular, B is non-regular. A comma B, both are non-regular. Then their union can be anything. Their union can be regular or union can be non-regular. Okay, is this clear? So this is what we have done for union. Now similarly, can you notice for intersection? If A regular, B regular, intersection will be regular. Okay, because we know regular intersection regular, that is regular. Yes or no? Regular intersection regular, that is regular. What about this? Regular intersection non-regular, what you can say? Regular intersection non-regular, what you can say? Please tell me. Regular intersection non-regular, what you can say? That can be anything. Can you give me? Means A is regular, B is non-regular. Give me languages. Now what you do? You give me languages where intersection is regular. Okay, make sure that intersection is regular. Give me such languages, and give me such languages where intersection is non-regular. Give me A regular, B non-regular. Give me two languages such that their intersection will be regular. Yes, for example, you can take A equal to 5. You can notice this is regular. And you can take B equal to A power n, B power n. This you can notice this is non-regular. Now you can note their intersection is 5. Here A intersection B, that is 5, which is regular. Okay, another example, A must be regular. So let's take A equal to sigma star. And B must be non-regular. So you can take A power n, B power n. What is their intersection? Please tell me. What is their intersection? Their intersection will be B, which is non-regular. Correct? Okay. So quite easily you can do. So you can notice, if A is regular, B is not regular, then in this situation, what will happen? The result can be anything. Okay. Similarly, you can see this, and similarly you can see this. So I hope you are comfortable with this complete. This is not a table. This is questions, a lot of questions. Yes or no? A lot of questions. All of them are questions. For example, look at this. Look at this complement. Regular complement will be regular. Non-regular complement will be non-regular. Yes or no? Are you comfortable? Regular complement will be regular. Non-regular complement will be non-regular. Similarly, reverse. Regular reverse will be regular. Non-regular reverse will be non-regular. And what about this one? Regular whole star will be regular, but non-regular whole star can be anything. Yes or no? Yes or no? But non-regular whole star can be anything. This we have already seen. We have already seen this. And similarly, you can see concatenation. If A is non-regular, B is non-regular, then the result can be anything. Then the result can be anything. And if A is regular, B is regular, then the result will be regular. Okay. So I hope you are comfortable with this. Please tell me. Anyone has any doubt in this? Let me know. In this this is a set of questions. All these are questions. So many questions. So many questions. All of them are questions. Please tell me. Anyone has any doubt in any of them? We have already seen. For example, this we have seen, right? Non-regular whole star that may be regular, that may be non-regular. This we have already seen, if you remember. We have seen everything in this table. Let's move on. Don't remember this table. Don't remember this table. This is just a set of questions. This is just a set of questions, nothing else. Let's move on. Okay, so this is just a set of questions. Tell me the answer for this question quickly. Quickly tell me the answer for this question. Now I am saying Lm is regular. Lm is regular. L dot m, that is regular. So what is possible? What is possible? Tell me. I am asking what is possible. Lm is regular. So what is possible? Is it possible both can be regular? Is it possible? Tell me. Lm is regular. Lm is regular. Is it possible both can be regular? Yes, it is possible. Regular dot regular is regular. So this is possible. Is it possible both are non-regular? Is it possible both are non-regular? Is it possible both are non-regular? Both L, M are non-regular. Yes, this is also possible. We have seen, if you remember. If you remember, I told you non-regular dot non-regular may or may not be regular. If you remember, may or may not be regular. This we have already seen. Okay, so this is possible. Option A is possible. What about option B? Is that possible? What about option B? Yes, that is also possible. That is also possible. All of them are possible. Yes or no? I'm asking what is possible. All of them are possible. Okay, all of them are possible. Now tell me the answer for this question. Now I am saying Lm is non-regular. Lm is non-regular. This language Lm. This is non-regular. This is non-regular. Now tell me. Lm is non-regular. Now tell me. Is it possible that both are regular? Is it possible? Is it possible both are regular? Is it possible both L, M are regular? Is it possible both L, M are regular? This is not possible. If both are regular, then this will be regular or not? Yes or no? If both L, M are regular, then this will be regular. If both are regular, then this will be regular. Both L, M are regular, then this will be regular, but it is given it is non-regular. So this is not possible. Everything else is possible. This is possible, this is possible, this is possible. Is this clear? So can I say if Lm non-regular, if Lm is non-regular, can I say then at least one of them will be non-regular? Yes or no? Then at least one of them will be non-regular. Then at least one of them is non-regular. Agree with me? Please tell me. If Lm is non-regular, then at least one of them will be non-regular. Both cannot be regular, because if both are regular, if both this is also regular, this is also regular, then this will be regular. Okay. So you already know regular dot regular is regular. Regular dot regular, that is regular. So I can say if LM is non-regular, then at least one of them must be non-regular. Okay, so this is the table. Again, you can see these are questions. All of them are questions. Are you comfortable? Regular dot regular is regular. Is this correct? The first one, is this correct? Tell me. The first one, regular dot regular. Is this correct? Yes. What about the second one? Regular dot non-regular. That may or may not be regular. This is also correct. Non-regular dot non-regular. This may or may not be regular. Correct. If L dot L1 dot L2 is regular, then anything can be possible. Yes or no? Then anything can be possible. Then anything can be possible. What about this? If L1 dot L2 is non-regular, then at least one of them is non-regular. If L1 L2 are non-regular, if L1 dot L2 is non-regular, then at least one of them is non-regular. So these are questions. Don't remember all these things. Tell me, will you by heart all these things? Everything that we have seen, will you by heart? Tell me. Will you by heart anything that we have seen? Will you by heart? No. Just understand everything. Just understand everything. If you by heart, then you will make mistake. If you by heart, if you do rote learning, then you will definitely make mistake. Okay, so don't do rote learning. Just understand everything. Tell me the answer for this question quickly. Let's see, did you understand or not? Let's see. If L union M is regular, L union M, that is regular, then what is possible? I'm asking possible. Then what is possible? L union M is regular. Can both be regular? Tell me one by one. Can both be regular? Yes, both can be regular. Both can be regular, right? L union M is regular, so both can be regular. If both are regular, that is fine. Regular union regular is regular. Is it possible both can be non-regular? Is it possible both can be non-regular? Is it possible? Yes, both can be non-regular also. L union L complement. Is it possible one of them is regular, another is non-regular? Is it possible one of them is regular, another is non-regular? This is also possible. Sigma star union L. And this is also possible. L union sigma star. Yes or no? So all of them are possible. Tell me the answer for this question. Union is non-regular. I am saying this union is non-regular. This union is non-regular. What is possible? Union is non-regular. What is possible? Tell me. I am saying union is non-regular. Tell me, both can be regular. Is it possible? Both can be regular. Both regular. Is it possible? No, it is not possible. It is not possible. Both non-regular, possible. This possible. This possible. Okay, all of them are possible. For example, here you can take L union phi. Here you can take phi union L. Okay, so everything is possible. Now, tell me the answer for this question quickly. L intersection M is regular. Then what is possible? Intersection is regular. Then what is possible? Intersection is regular. Both can be regular. Yeah, possible. Both non-regular. That is also possible. This is also possible. This is also possible. Everything is possible. Tell me the answer for this question. Intersection is non-regular. Intersection is non-regular. Now what is possible? Intersection is not regular. Is it possible both can be regular? Is it possible both can be regular? No, it is not possible. Everything else is possible. Tell me the answer for this question. Use the closure properties to show that this language is context free. Use the closure property to show that this language is context free. Your language is what? Your language is WW reverse. WW reverse, where W belongs to A, B whole star, where W belongs to A, B whole star, and W length is not equal to 2. So how to prove that this language is CFL? Using closure properties. Using closure properties. How to prove? See, this language can I write like this? This language can I write as WW reverse? intersection what? Intersection all strings whose length is not 2. Tell me, can I write? Tell me, let me know. See what I'm saying. I'm saying that, just wait. I'm saying that, no, this is not correct. W length is not equal to 2. Okay, so actually 4. I should say 4, right? Yes or no? I should write 4 here. Because if W length is 2, then this will have length what? Tell me. If W length is 2, then this will have length 4. This will have length 4, right? Yes or no? So can I say, is this correct? WW reverse, you have all the strings of WW reverse, intersection these strings. Okay, intersection these strings. So the common strings will be what? Tell me what will be the common string. See, common strings will have this form. Yes or no? Common strings will have this form. Common string will have this form, and common string cannot have length. In the common strings, you can notice they cannot have length 4. Yes or no? The common strings, they cannot have length 4. Please tell me, is this clear? The common strings. So you can notice, okay, such that length of W is not equal to 2. This will be your L. I hope this point is clear. Please tell me, did you understand what is this? Please tell me, did you understand how did I do this? How did I do this? See, very simple. Here you have WW reverse such that W length is not equal to 2. See, notice, if W length is 2, then its length will be 4. Okay, so means its length should not be 4. This should not have length 4. So your final answer will be, I can say this language is WW reverse intersection this. Now you tell me what is this language? Tell me what is this language? Let me know. What is this language? This language is context free. And what is this language? This language is regular. What is regular intersection context free? What is regular intersection context free? That will be context free. That will be context free. Okay, so we have proved that this language is context free. We have proved that this language is context free. Yes or no? Is this clear? Now let's see this question. Quickly tell me the answer. See, this question is saying, question about closure property of context free languages. This is the question. You will get 8 points. If you give me answer, you will get total 8 points. The question, the first statement, tell me the answer for the first statement. Just read the first statement. Is this true or false? Just focus on the first statement. First statement for 2 marks, for 2 points. Tell me about the first statement. If L2 is regular and L1 intersection L2 is regular, then can I say L1 is context free? Of course not. Of course not. See, L2 is regular. This is given that L2 is regular. L2 that is given to you as regular. And the question is saying L1, L2 is regular, L1 intersection L2 is regular. Okay. Now, for example, this is possible that maybe L2 is 5. Yes or no? Maybe L2 is 5. Agree or not? Maybe L2 is 5. And maybe L1 is A power N, B power N, C power N. Now tell me what is L1 dot L2? What is L1 intersection L2? Tell me. Tell me what is L1 intersection L2? That will be 5, which is regular. But L1 is not context free. But L1 is not context free. Is this clear? Please tell me. But L1 is not context free. So this statement is false. Did you understand? Please tell me. Let me know. Did you understand? See, if L2 is regular, L2 is given to you, that is regular. Also, it is given that L1 intersection L2 is regular. These two things are given. These two things are given to you. These two things are given to you. Does it guarantee that L1 will be context free? From these two things are given to you. L2 is regular. L1 intersection L2 is regular. From this, can you guarantee L1 will be regular? L1 will be CFL. From this, look at this. Look at this and tell me, can you say L1 will be context free? No. For example, you can take L2 equal to 5. You can take L1 equal to A power n, B power n, C power n. Now your intersection will be 5. These conditions are satisfied, but L1 is not context free. Yes or no? These conditions are satisfied, but L1 is not context free. Okay, so this is false. What about the second statement? Please tell me. Now forget about these things. Forget about these things. Tell me about the second statement for 2 marks. 2 points. Can you get these 2 points? Please tell me. If L1 is context free, L2 is regular. L1 is context free. L2 is regular. Then what is L1 minus L2? That is context free minus regular. Okay. That is nothing but context free intersection regular complement. Regular complement is regular. Regular complement is regular. And context free intersection regular, that will be context free. So this statement is true. Yes or no? Yes or no? This statement is true. Agree or not? This statement is true because L1 minus L2, CFL minus regular. That means CFL intersection regular complement. Regular complement is regular. CFL intersection regular is a regular. CFL intersection regular, that is CFL. So this statement is true. What about the third statement? Tell me about the third statement. Forget about the remaining now. Tell me about the third statement. Can you get 2 marks? 2 points can you get? If L1 dot L2 is CFL, then can I say both are CFL? Then can I say both are CFL? This statement is false. Can you give me counterexample? If L1, L2 are CFL, L1, L2 are CFL, can I say both are CFL? This is false. Can you give me counterexample? Take L1 equal to 5. This is CFL. Take L1 equal to 5. Take L2 equal to A power n, B power n, C power n. Now tell me what will be L1 dot L2. Tell me. Tell me what will be L1 dot L2. Take L1 equal to 5. That is CFL. L2 is not CFL. Okay, L2 is not CFL. Tell me what is L1 dot L2. That is 5. That is CFL. So can you notice L1 dot L2 is CFL, but it does not mean that both will be CFL. It does not mean that both will be CFL. Yes or no? So this statement is false. Please tell me, did you understand? Please tell me. See, this is given. That this is given. What is given? This is the given information that L1, L2, this is a CFL. This L1 dot L2, this is CFL. But this does not mean anything. Yes or no? This does not mean anything. This does not mean anything. What you can do? You can take, for example, L1 equal to 5, you can take L2 equal to A power n, B power n, C power n, you can take. Still what will happen? L1, L2 will be CFL. Here also L1, L2 will be CFL. So this condition is satisfied. This condition is satisfied, but you can notice both are CFL, that is not true. Both are CFL, that is not true. Yes or no? Both are CFL, that is not true. So this statement is false. What about the last statement? Tell me. Option D. Tell me the answer for option D. I want correct answer from you. Tell me the answer for option D. If L1 is context free and L2 is subset of L1, then L2 is context free. If L1 is context free, the question is saying if L1 is context free, L2 is a subset of L1, then L2 is context free. Is this true or false? This statement is also false. For example, you can consider L1 equal to sigma star. This is CFL. This is CFL. L1 equal to sigma star, that is CFL. Now you can take L2 equal to A power n, B power n, C power n. Is this subset of L1? Tell me. Is this subset of L1? Let me know. L1 is sigma star. You can take L1 equal to sigma star. That is CFL. So this condition is satisfied. You can notice L2 is subset of L1, but still L2 is what? L2 is not CFL. L2 is not CFL. Yes or no? So you can notice we have taken L1 is context free. We have taken L1 context free. We have taken L2 is subset of L1. That also we have taken. But you can notice L2 is not context free. So this statement is also false. Tell me how much marks you got in this question. Tell me how many marks you got. So only this statement is true. The remaining statements were false. How many marks you got in this question? Honestly, tell me. How many marks? Okay. So tell me, did you understand now? Now did you understand? Please tell me. Now did you understand? The question is this. Now are you comfortable with these questions? Did you understand these questions and their solution? At this point, you tell me. Now did you understand these questions and their solution? So quite easy. Okay. So that's it. That's all that we have seen. Okay. So anyone has any doubt? This is your closure properties. Closure properties of context-free languages, closure properties of regular languages, closure properties of non-regular languages, closure properties of DCFLs. Everything we have seen. Everything we have seen. We have seen everything. Only one topic is remaining, this. You might be thinking, under which operations regular languages are not closed? Yes or no? You might be thinking, under which operations regular languages are not closed? Regular languages are not closed. Under which operations? For this, I will provide you a recorded video. Okay? I will tell you all the operations under which regular languages are not closed. These operations I will tell you. Okay? There are 4 operations. Let me tell you. The 4 operations are subset, superset, infinite union, infinite intersection. Infinite union, infinite intersection. Don't worry. I will explain everything in a recorded video. You will get the recorded video today. Okay? All of them I will explain. Complete explanation I will give you. Okay? That regular languages are not closed under these operations. Okay? The set of regular languages, they are not closed under these operations. Subset, superset, infinite union, infinite intersection. Regular languages are not closed. Okay? So for this, I will provide you a recorded video. Today you will get it. Okay? So that's it. Please tell me, everything is clear? Are you comfortable with closure properties? I have told you every variation, everything I have told you. From the closure properties, any question they want to ask you, whatever the question they will ask you, I have told you. Okay? I hope you understood. Okay. So thank you, everyone. See you in the next session. Thank you.